Very good morning, students. In the series of chemistry lecture, I have already explained you about the mole concept, and the numerical based we have solved number of very good questions, varieties of the questions based on mole concept, molecule, atoms, electrons, ions, and so far as assignment is concerned, I am very happy because you have solved or retained many more formula and examples. Now the next topic is methods of expressing the concentration of solution. My dear students, anybody tell me methods of expressing concentration of solution? Concentration, you know, simply to compare the quantity between solute and solvent. There are so many parameters. It is a very wide spectrum of chemistry. Their chemists used to take molarity, ppm, formality, normality, mass percentage, volume percentage, as well as mole fraction. My dear students, today we take first parameter is the mass percentage. So mass percentage is actually what? You take a binary solution. Binary solution means two components should be there. In that binary solution, let WA and WB. A is the solute and B is the solvent. Let WA is the mass of solute and WB is the mass of solvent. So tell me anybody, total mass of solution is how much here? Total mass of solution WA plus what is there? WB. If we have to calculate mass percentage of A, then it is the ratio between mass of that component to the total mass of solution multiplied by 100. If you calculate the mass percentage of B, again you change the ratio WB upon WA plus WB to be multiplied by 100. The way you can calculate mass percentage, right? Then again you can change volume percentage. Same, let us consider a binary solution which contains two components. One is the solute, A is the solute and B is the solvent. Let VA is the volume of solute and VB is the volume of solvent. So total volume of the solution is what is that? VA plus VB. So volume percentage of A equal to VA upon VA plus VB multiplied by what is that? 100. Volume percentage of B equal to VB upon VA plus VB is to be multiplied by 100. The way you can calculate mass percentage and what percentage? Volume percentage. Third one is the strength of what is their solution. So it is defined as the amount of solute in gram in 1 liter of the solution. So the unit is, my dear students, gram per liter. It is very much temperature dependent because it is related with the volume. But mass percentage is independent of the temperature, while volume percentage very much dependent upon the temperature. So far as the strength of the solution is concerned, you can calculate the numerical given mass of solute in gram, volume of solution in liter. So what is the unit? Anybody? Gram per liter or gram liter inverse. So it is very much temperature dependent. So I provide you the numerical in my assignment class, you know, and the next one is the mole fraction. Anybody tell me what is mole fraction? It is the ratio between number of moles of one component to the total number of moles of solution. Always mole fraction of solution is found to be 1. If you get the mole fraction of A, then you can calculate the mole fraction of B. 1 minus whatever the value you get is to be subtracted. Right now, so it is the ratio between number of moles of one component. Let Na and Nv are the number of moles of A and B. So total, let A is the solute and B is the solvent. N is the number of moles of solute A and N is the number of moles of solvent B. Na plus Nb. My dear students, total number of moles is what is that? Na plus Nb. Mole fraction is represented as chi, Greek symbol. If I have to calculate mole fraction of A, then Na upon Na plus Nb. If we have to calculate mole fraction of B, then it is the ratio number of moles of B, number of Na plus Nb. The way you can get the mole fraction of the solution. Next formula which I will provide you is the molarity. Dear students, what is molarity? Molarity is actually number of moles of solute and volume of solution in what is there? Liter. So what is the unit? It is the mole per liter, and it is very much temperature dependent. How do you get the number of moles? Given mass upon molar mass. Concentration of molarity can be in different terms, may also be provided in your numerical, so far as the term used usually by the examiner in your paper. If m is equal to 1, or you can use the capital M is equal to 1, it is called unimolar solution. If m is equal to 1 by 10, decimolar solution. If it is 1 upon 1000, millimolar solution. If 1 by 2, it is semi-molar solution. If 1 by 5, it is pentimolar solution. If it is the 1 by 10 decimolar, okay. If it is the 5, then you can say it is the pentamolar. If it is the 10, it is the decamolar solution. The way concentration can also be given in that way. Secondly, for the dilute solution, for you use this formula for dilute solution. Here M1 V1 equal to what is there? M2 V2. Out of 4 parameters, 3 are given, 4th can be calculated. If we have to calculate M2, then it is the M1 V1 divided by what is there? V2. Same formula you can apply here for normality. N1 V1 equal to what is that? N2 V2. I'll discuss on right time what is normality. But this time you can use, instead of N, we write here N, and it stands for normality. So this is the word. Whenever you get the word in the numerical dilution, then you apply this formula. Next formula for 2 unknown substances. Next formula is for, you can see here, then before that. If percentage is given and density is given, then how can you calculate molarity? I'll be very good formula that is very widely used, right? For percentage of solute and density. D stands for what? Density. Therefore, you can calculate molarity is equal to percentage of solute into 10 into D upon what is there? Molar mass of kiska molar mass? It is the solute. Second, for two unknown type of the substances, then molarity MV equal to M1 V1 plus what is there? M2 V2. Total volume is here. If you have to calculate molarity, then V1, M1 V1 plus M2 V2. Data are given. You can calculate molarity, and here this volume means V1 plus what? V2. It's alright. So far as normality is concerned, N1 V1 plus what is that? N2 V2. Yes friends, for 2 different substances, so far as acid as well as base is concerned, then MV equal to M1 V1 minus M2V2, or normality into volume is equal to N1V1 minus what is there? N2V2. It's alright. Then in case of another formula, you have to calculate the molality, or even molarity is given and density is given. Then I give you again a very good formula to calculate molality. Dear students, I discuss molality this time. You will see. This is the first you write the formula. If you have to calculate molarity, 1000 into molarity upon 1000 into density minus molarity into what mass? Molar mass. the way you can calculate molarity. So 1000 into molarity, that given, density given, molarity given, molar mass you can calculate, and you can have the right answer. See, the next is what is molarity? My dear students, chemists used to prefer molarity rather than the molarity. What is the fundamental cause of this? What is the reason behind it? Because molarity is temperature independent, but molarity depends upon the temperature. No doubt molarity is more convenient than the molarity, but actually molarity has the authentic answer, accurate answer than the molarity. So chemists used to prefer this one, molarity, but not the molarity. So actually, what is the molarity? Molarity is the number of moles of solute, mass of solvent in what is there? In kg. So it is the mass relation. But molarity was mass volume relation. So what is the unit of this molarity? Mole per kg, or it is very much temperature independent. So chemists use to prefer molarity rather molarity. Is it clear to you? So tell me, which is more concentrated, 1 molar solution or 1 molar solution? So obviously 1 molar is more concentrated because number of moles of solute in 1 liter of solution. Dear students, solution includes solute plus solvent, but molarity is not actually that. Molarity is the number of moles of solute and mass of solvent in kg. So the way molarity is not highly concentrated than the molarity. Then after that you can see ppm. ppm is what actually for microscopic substances, there you can use ppm. So if you have to calculate parts per million of A, then mass of A in terms of volume, in terms of moles, whatever it is, mass of solution to be multiplied by 10 to the power 6. For example, presence of argon in the air, scientists can apply ppm parts per million. 1 million is 10 to the power 6. If you want to calculate calcium ion and magnesium ion in hardness of water, ppm is used. If you want to calculate presence of chlorine in potable water, because excess chlorine is very carcinogen, therefore ppm is applied. If you can calculate presence of chlorine in the toothpaste, there scientists used to prefer ppm. Very simple. It's the parts per million of the solute in solution to be multiplied by 10 to the power 6. And then next is the formality. You know what is formality? Yes, formality is for ionic substance. There is no any fundamental difference between molarity and formality, but formality is applied for the ionic substances. So formality is same way, number of gram formula weight of solute and volume of solution in what is that? Liter. If you are given a numerical 234 gram of NaCl is dissolved in 4 liter of water. What is the formality? So 234 divided by 58.5 molar mass of NaCl into 1 by 4. Then you can get what is that formality. Then after that you can see and solve. You can solve this question. 234 gram of NaCl is required to prepare 4 liter of what is the solution. What is formality? So formality is the number of gram formula weight. That means number of moles. 234 58.5 into volume 1 upon 4. I think it is the one formal solution. So my dear students, we have explained today the different parameters by taking the concentration. First is the mass percentage, volume percentage, strength of the solution, then mole fraction, then molarity, and then you can say formality as well as ppm. Right. So in next class we'll discuss about normality, because of if you discuss normality then you have to take equivalent mass of substance, equivalent mass of atom, ions, acid, base, salt. So till that I hope you have to go through all this formula and retain all this formula, and you will apply or implement this part if you will solve good number of numericals which I will provide you from your textbook from time to time. Thank you very much. Have a nice day. God bless you.